I just came back from maternity leave, and honestly, I felt like I've missed years in the last 6 months. I've spent the last decade and a half designing cloud systems, and even I felt left behind. AI friend from a thing people were just experimenting with to a thing everyone's apparently building with, and I had no idea where to start. So, this series is me rebuilding my AI mental model from scratch and bringing you with me. No math, no expert level coding, just real problems, the architecture underneath, and honest notes on where things might break. So, if you want to learn AI, ride along. Every episode will have the same shape. You can skip sections if you like. There will be a problem, there will be a quick demo, something that actually works or maybe doesn't work, the architecture underneath in plain English language, where it will or it might break, what to try next, whether you're just curious or you want to build. No fluff, just useful. Okay, let's start with the sample scenario. Saturday night. I have 6 people coming over. One's vegan, one's gluten free, and I want to look like I know what I'm doing in the kitchen. So I'm going to paste a real recipe in here. And I'm going to ask it 3 questions, each one a little more interesting than the last. What are the core techniques in this recipe? Strip off the fluff. Okay, so it's telling me the core techniques in Hyderabadi biryani, which I love, is fried onions, the barista, the marination, the rice, the layering, the dum cooking, and the key principle is that the chicken cooks raw to done inside the sealed pot using only trapped steam. So sounds good. Now you would say, isn't that a fancy search? Yeah, fair, fair. Let's begin. Let's go with our next question. So I'm going to paste another question. I'm going to ask it, looking at this recipe, what's the thing that's most likely to go wrong for someone who is cooking it for the first time? So the biggest risk, okay, it's telling me it's the cooking stage, it's specifically overcooking the rice, makes sense. For first time, what goes wrong is 75% is done, is vague if you never felt it before. Exactly, like people tell percentage about rice is like, as if like I know how to cook biryani every day. And the second risk worth mentioning is undersalting the rice water. Oh, I did not know that you have to salt the rice water. So that's a great response, right? Now this is something a search tool will not genuinely do. It's actually reasoning about the recipe itself. It's not just reading it and giving me a text out of that recipe, right? It's actually spotting where people might usually mess up in this recipe. Sounds good. Now let's ask it a third question. My third question is, I am cooking this for 6 people on Saturday. One is vegan, one is gluten free. Adapt this recipe for me. Give me a shopping list. And the last thing is, give me a timeline starting from 4 p.m. Now let's see what the response is. So adaptations first. Great. So for the vegan option, you can separate out roughly marinated chicken. Okay, use coconut yogurt instead of dairy yogurt, replace the ghee. Okay. I didn't get this part. What does this mean? Okay, but we'll see. Cook a small separate vessel, vegan option, gluten free. This recipe is naturally gluten free, which is great. Gave me a shopping list. It also told me a timeline, right? Great. And it told me from 4 p.m. Okay, 4:30, prep and rest. Great. And is it taking me 15 minutes to drain the rice? Okay. And awesome. Awesome. So it's given me all the information and it's given me some added notes as well. Now this is great, right? Because I just asked for something that I'd naturally spend maybe 20-30 minutes just thinking about, making a list and wondering how to adjust this recipe and so on and so forth. And it's giving me a great starting point in 10 seconds. Here's what actually happened when I typed that question. I sent the input text, we call that a prompt, to a foundational model. Now you'll hear that term a lot, foundational model. It just means it's a big model that has been trained on a huge mix of data for your regular day to day general purpose. Claude, GPT, Llama, Mistral, those are all foundational models. We'll meet a few of those properly across the series. Now, the model itself is just a piece of software that's been trained on an enormous amount of text, books, articles, code, conversations. It's not really searching the internet right now, and it has learned all these patterns from all that text beforehand. So, when I give it a prompt, it actually predicts the most useful response based on everything it has already learned. Input goes in, model is predicting, and then output comes out. I've been building distributed systems for years, and a foundational model call is simpler than most APIs that I'm used to. So it is like an HTTP request with the text coming in and text coming out. But the complexity is not in the call. The complexity is in what that model has learned before you and I ever showed up. And this is exact loop is what this entire AI wave is built on. Every time you see a new Claude or a new GPT or a new Llama Land and people are losing their minds, that's what's actually happening is that someone has trained a bigger or a smarter version of the same idea. Just the same loop, more data, and better prediction. However, that is not the case all the time. The model is confident, it sounds right, right? But it doesn't actually know that it is right. It's simply predicting what a useful answer will look like. So sometimes that prediction is brilliant, and sometimes it invents an ingredient swap that would genuinely ruin my dinner. So we're going to talk about this all, why this happens, in episode 2. For now, just notice it. Every time you use one of these tools, ask, what would I need to double check before I actually trust this fully? You might have noticed I wasn't using ChatGPT or Claude's own website. I was using something called Amazon Bedrock. Bedrock is where a bunch of these foundational models live on AWS. Anthropic's Claude, Meta's Llama, Mistral, or Amazon's own models. They are all callable through Bedrock. You don't need to run or train anything yourself. And the playground is just the easy way door in. Later in the series, when we start building code, we will actually call the same models from our code. The same models, just different doors. Quick thing I want to be upfront about. I work at AWS, so the tools that I am going to show across the series, be it Bedrock for the models or later on we'll use something called as Kiro, the concepts though are not AWS specific. Foundational models, tokens, context windows, rags, and agents, they all work the same way everywhere else. There might be small nuances wherever you go. So I'm just showing you my stack. So here's what I want you to take from today. If you're just getting started, go try this yourself. Open any chat AI tool, Bedrock Playground, Claude, ChatGPT, whatever works for you. Paste a recipe, a contract, a long email. Ask it maybe 3 questions. One to summarize, one to interpret, or one that's maybe personal to you. See what happens. And that's your homework. If you're more on the builder side, the mental model is simple. Text in, model, text out. Everything we will be building in this series is a variation of that loop. So next time we will talk about why AI sounds so confident while being completely wrong. How do you spot it? And most importantly, how do you even stop it? Right along. Bye bye.